Okay, so some of you guys asked about the other two review squares for our NeSA test next week. It just some things you can kind of review or sketch a few times, or if you want to even draw them that day, just to help you kind of work through some of the physical science and the life science stuff. So sorry you can't see that fold that goes right here, but when we're talking about physical science, one of the major things you might see is the changing of different states of matter from, a solid to a liquid or a liquid to a gas or whatnot. So the big thing to keep in mind is that when we change states of matter, the three states are gas, solid, and liquid, that's all determined by the temperature. So temperature dictates when I change from a gas to a liquid or from a liquid to a solid or vice versa. So every state of matter can go both ways. So solid to liquid, that one's usually remember that, melt and freeze. Gas and liquid, we usually remember from the liquid to a gas pretty easily, that it disappears, so it's evaporating. But a gas to a liquid, as that gas kind of cools, it comes back together to form the liquid bonds. And then it condenses, so condensation, and then you have deposition and sublimation for the gas-solid interactions. So those ones are a little bit different. Sometimes we don't remember this, but this happens like one of those jelly cone air fresheners that Miss Young has in her room. That starts out as a solid, and then it sublimates, and slowly it turns to a gas without ever turning to a liquid first. Like it just disappears and turns to a gas. Another example of that is when you put ice cubes in the freezer. If you guys have ice cubes and they stay there for a really long time, one day you'll open up your ice cube tray or ice cubes and they're smaller or they've disappeared completely. That's because that solid is actually just sublimating and turning to a gas. Gases can go right to a solid as well. This happens a lot of times when it's you'll see it when it's super cold outside. The atmospheric gas will deposit itself and form like frost in the morning or something. So frost on your windshield, frost on the ground. That's not happening because it's, raining or anything. A lot of times it's just depositing itself. It gets really cold really quickly and becomes a solid. So that state of matter kind of review is important. The other thing with a physical science is reviewing how elements make up molecules and compounds and mixtures and the differences between them. So an element is just one type of atom. So like here, a little purple dot. So an example of this could be like carbon, shown with a letter C, or hydrogen, shown with a letter H, or oxygen, shown with a letter O. So think about periodic table there for elements. A molecule then is actually, two or more of that same element. So two of these little guys become C2, carbon 2. Or if I had ozone, for example, ozone formula is O3, so it's 3 parts of oxygen. So that would be a molecule. It's just it's clumped up together of the same kind of element. A compound then, using our word parts, means with or together, is 2 or more elements. They're different and they're chemically combined. So an example of a compound would be water, H2O. So the two elements are hydrogen and oxygen. And then if you really zoom in, you can see there's actually a molecule of hydrogen here too. So compounds are 2 or more elements put together. Another one would be table salt, which it looks like sodium chloride. So that's NaCl. You'll see those elements kind of bonded together there. Big thing about compounds is once they're formed, they're kind of difficult to get them apart because they're chemically bonded together. They don't break up real easy. So it takes a lot of energy to break them up. So you can't just pull off a hydrogen from that water compound. It doesn't break up easy because it's super bonded together chemically. And then the last kind of thing to think about are mixtures. Mixtures are just a conglomeration of different things. So I gave an example of lemonade and water. Like lemonade powder can maybe be the purple, and then water would be the black. I just mix that together. Another example would be like sand and gravel, or even boys and girls in the classroom. The big difference between mixtures and compounds is that mixtures can be easily separated. I can separate the boys and girls from the classroom. They're not chemically bonded together. They're just mixed. I can actually separate lemonade and water. if I make lemonade with lemonade powder or Kool-Aid and I mix up the water in there, and I want the lemonade back, what I can do is I can just, I could do a couple things. I just need to get rid of that liquid so it takes us back up to that triangle up above. I could just let my lemonade sit out on the counter for, a week, and you're going to see that water evaporate, and all you're going to be left with is the lemonade powder. Or I could speed it up, and add, maybe boil that water out of there, and then you can go ahead and just have the lemonade powder back from that too. So mixtures can be easily separated. Then the final thing on the physical science square that I had down here is just force diagrams. When we're talking about adding or subtracting forces, those pushes and pulls on objects, you might be asked on what does that mean or what do they need to do. So the big thing is a lot of times they will give you the forces in which direction it's happening. So like in this first little diagram here, I have 10 newtons pushing from behind and 10 newtons pulling. So it's like me and Mr. Merriquin are trying to move a piano together. So he pushes the piano and I pull the piano. Because we're working with the same direction, we're actually helping each other. So then I just add those two forces up because I'm working together. And so my total net force would be 20 newtons to the left. So another example would be, maybe I'm pushing on the piano with 10 newtons and Mr. Merriquin is pushing on the piano from the opposite side with 5 newtons. We're working against each other. We're essentially arm wrestling. And so if I work against you, if I'm going in opposite directions, I subtract those forces, and so I would come up with a net force of 5 newtons. And because I'm a beast, I'm stronger than Mr. Merriquin, I'm actually applying more force, so the piano would actually move towards the right as well, so with 5 newtons that way. And then you might have an example where maybe when you add them up or subtract them, it comes up to be 0. If you come up with a 0 net force, it just means that there's no change in motion of the item. It's not going to change directions or speeds or maybe even move. It's nice and balanced. It's just going to kind of hang out there. So that's kind of the nice review for physical science. Life science, some things here, some organization things. If you start kind of down here where I started, we start really, really broad with the biosphere. A lot of word parts here. So this is really where life is existing. So the biosphere is where we have everything living. And then you zoom in a little bit to a specific biome. So maybe I zoom into the tundra or the grasslands or the desert or something like that. So it just changes its temperature and its precipitation there. You zoom in a little more and you become like, the Plum Creek Park ecosystem. It's just when you're in an ecosystem, you're talking about everything that's biotic and everything that's abiotic. So everything that is living, everything that is non-living. All the plants, animals, bacteria, everything, plus all the water, the temperature, the dirt, and that stuff. So ecosystem is living and non-living, biotic and abiotic. Then you zoom in a little bit more and you get to the community. Again, that word part co comes up. We know it means with or together. So now I'm only looking at the lions and tigers. Okay, so again, if I go back to my Plum Creek Park, I zoom in, I get rid of the dirt, I get rid of the air, the temperature, the water, and I only have, the different plants that are living together with the different animals or birds, all those things. Just the living stuff that is living together is your community. And then you zoom in a little bit more and you just have your population. This is just one type of living thing. So, think about like the Seward population. It's just people. We're not really thinking about, the dogs and the cats and the bacteria and the plants that live in Seward. We're just talking about the population of Seward. It's just counting the people. So population is one type of living thing. And then you can zoom in any more a little bit and you have the organism, and that's just one living thing. So that kind of organization is important. The other thing that's important is when we talk about food chains and energy. So I drew a little food chain. We know that the sun starts off all food chains. Then you have producers, which could be called autotrophs. Auto, They self, and then think troph, like I'm eating out of a trough. They self-feed. They produce their own food. That's like a plant. So any corn, grass, trees, any of that stuff that goes through photosynthesis is a producer. They make their own food. And then they pass their energy on to a primary consumer, which could be like the herbivore. So that'd be like a worm in this situation. And then that energy gets passed on to secondary consumers. And then that could go on for several links. But the most important thing too is to keep in mind is that decomposer always ends it and recycles everything back to your producer, basically. So that's a nice kind of food chain example. Webs look like webs. It's a lot of different food chains all, hooked up together. And energy pyramids look like energy pyramids. Like you'll see an actual pyramid and, it'll even kind of look like this guy down here, but it'll have different organisms in there. So that's the little feeding relationship. Going back to organization. So if I zoom way into that organism, that living thing, all living things are made of cells. Cells work together to build tissues. Tissues work together to build organs. Organs work together to build whole organ systems like the digestive system or, something like that. And then organ systems work together to build organisms. So, if we think about that, we have, a cell that builds up smooth muscle tissue. And then smooth muscle tissue builds up the stomach. And then the stomach and the small intestine and all those guys build up the digestive system. And then all the digestive system, the circulatory system, the respiratory system, the nervous system all work to build up the organism. So it's just building blocks getting bigger and bigger. Then the last little thing that might be helpful for life is looking at those symbiotic relationships. So sim is a word part that means with or together. Like I'm showing sympathy with you. You're in a symphony with somebody. I have symptoms of an illness. All those things are with somebody. And then bio is life. So that literally translates into living together relationships. And there's three main ones. There's one where you're happy. Both of the organisms are getting benefit from this. So it's kind of like you scratch my back, I'll scratch yours. And when that happens, it's mutualism. They're happy about being in that relationship. They work together. A big one, like you'd see is like the birds that walk around in the mouths of the crocodiles. The mouths are wide open. The birds trust the crocodiles. The birds are getting fish and that makes them happy. It's a free meal. And the crocodiles are getting dental hygiene, which is important for the health of their mouth. And so they're happy that, they can continue to eat easily because their gums are nice and clean and healthy. So that would be mutualism. Parasitism is when one thing is hurt or sad and the other thing is happy. So parasites, like a tapeworm and a puppy. The tapeworm's happy. He's getting everything he needs. He's getting nourished. The puppy is sad because it's sick. It's getting sick from that relationship. There's all kinds of parasites, ticks, fleas, even mistletoe is a parasite. Mistletoe is a plant that wraps itself around another tree like an oak tree. So the mistletoe is happy because it basically sucks and drains the nutrients from the tree. It's dying.